Welcome to Devlog 6. Just to recap, designing the system that imports geometry. I'm using USD. This is an example of the text file that it's passing. So what we want to do now is, well, we want to check that this header's there. We want to skip this part. None of the information's used, or maybe this later on. And then every time it comes across with a definition, I want to grab all the text for that definition and throw it in a container. Then I want to grab all the text for this definition and throw it into another container. So this container will contain the planes, or the polygons basically, in this case, including texture coordinates, the actual vertices, normals, indices to the vertices and so on, as well as what shader's being used. In this case it's a texture file. So I've changed the file slightly, so this is my 3D app. So it's now a quad polygon. Here's the first vertex, second, third, fourth. The winding is anti-clockwise to show that this is the front of the polygon. And all the UV information here as well. First UV, second, third, fourth. And the texture information. So there's the texture file, the JPEG. And this all gets exported out to the USD file. Because it's ASCII, it has a USDA. USDC is the binary version. Later we'll do the binary version. A file that ends with .usd can be either ASCII or binary. So it's one of the quirks of this file format. And it's been version 1 since forever. So I'm not actually happy with the way I've started this. I'll just run it. So far it's identified the header. It's been correct. The first polygon, the only polygon, and the light information. It's a point light. Yeah, so I actually changed the point light. Yeah, so you notice I'm trying to explain more as I do the videos. I had one viewer suggest that I do that, so I was just silently typing away, being confused at my compiler. So moving forward, hopefully I'll try and explain things a lot better than I have in the past. This point light has an intensity of 1.5. It has a position. It's got color information. Red is 0.95, green is 0.9, blue is 0.8, intensity 1.5. And that's reflected in the text file that it puts out. So there's intensity, translation, the color of the light, and of course what type of light it is. It's a point light. So that's really all I need right now, is to be able to put geometry and lighting information. In the future I'll include animation data and bones and probably deformations, a whole bunch of other things. So this file format, the USD file format, easily allows for that in a very efficient way, especially in the binary format, which we might move to later. I didn't use a .obj format, which is a lot simpler, but it basically has polygon information and very basic texture information, and that's about it. But it's a very simple format to pass. But it doesn't have animation and other things, so I might as well just not use that at all and just stick with this. And in the future I might include Blender and Maya, 3ds and so on as file formats to read in. But that'll depend on how much time I've got available to do that. So let's get into the coding. So I actually want to create another class that contains each chunk of or basically each definition, and it puts that into an array. So the first pass will just, as it's going through, it will throw the text into the relevant class array. One for light, one for lights, another one for polygons, and so on. And the second pass will then go through and extract the information that I can throw into the GeoResources class, which holds vertex information, material, including normals and UVs and so on, and anything else in the future that I want to add to that. So let's just start with a new class. Because this is basically a dynamic array. That's what a vector class is. So you can keep expanding the size of it without having to worry about the memory management. It's all done in the background. If I chose something like array, that's a static. So it's a fixed size. Sort of more the traditional C++ array. But we want to... Vector's just so versatile. I always like to use a suffix underscore array at the end of a variable, because I find it useful just to know that, hey, this is an array, this is something I'm going to iterate through, pull the data from. And it's added debug, because why not? And chainable. I'll do the debug class now. It's a very simple class, it's only got 2 things in it. So let's just loop through all the lines that are kept, all the text lines that are kept in this array, spit it out to the screen. I'll put a counter in here. Okay, just make sure this compiles. Yeah, so that's done. so this is step 1. Ensure header is correct. So we just want to read that. Now we just want to ignore the rest of that. Return false. Yep, it goes up to here. Returns false back to the original. Read file. The reason why I have read file and read stream is in the future I might, instead of reading the files, I might be reading it from a stream, which could be a file that's already open. It could have packed information about a whole bunch of assets for the game. It could be all contained in this one file for the particular map. So the map might have a whole bunch of images and sound files and all kinds of things. So I want to just be able to pass it the stream. And in fact, in the future, I might give it a range where it starts and where it ends, just to make sure I don't accidentally move into the wrong part of the stream. So I'm just building in some flexibility now. Okay, this is the first pass. So we want to make sure that all this gets ignored. So I think I just wanted to redo this loop. So this is basically converting just a string, just a normal string, into a stream. So we read on a line, so like, here's a line, there's another line, there's another line, that's a line, that's a line, and so on. So we've just read on the next line, which is that one. But now I want to treat it like a stream so we can look at each word in that. Just step through it. So now just grabbing the first bit, which could be that. Could be that, could be that, could be that. That's the one we want. So, I'm going to reach its type. Yay, def found. So there'll just be two of these, one for the plane and one for spearlight. There's a few defs found. It just keeps looping through and it's only looking for def. as the first word in the line that it read. More diffs. There's one. Oh, there we go. There we go. Yeah, scope. There's material stuff there. So let's grab the next word. What sort of def is it? What kind of def? So if it's a mesh. We'll spit it out. So it should be just one of these. Okay, one mesh. So I may later put these in a map, which is another type of container. It's essentially a dictionary lookup, rather than having all these if and else if statements. I'll make the code a bit more elegant, probably a bit more better in terms of being able to expand stuff in the future. A bit tighter. Right, so we should just have one of each of these now. Yeah, one mesh, one spear light. And I might create a method to be able to generically handle each different type of definition. But just for now, I'm just going to write the code in here. So we just create a temporary object. So we've written def, we've written mesh. The next thing is the name. So we'll read that from the stream, that line. Put it in our object. Grab all that stuff. Yeah. So our next line, we'll just create another loop. There's nothing else in this apart from that. So the next line's going to be that. The next line's that. Then we want to grab that. So when we get to there, that's where we want to stop. I mean, we could have put that logic in here. I think it's just cleaner putting it here. Yep, no crash. So we basically want to grab that. Everything from here, probably excluding the curly brackets, to here. So we're going to count them. So that's 1 curly bracket, 2, another 2. They appear in sets, but if we just in case it goes negative. So we want ignore, yeah. So before we do that, we want to ignore everything until that's just in case, for whatever reason, there's other information in there, which I don't think will happen. Oh, come on. Just grab the next line to make sure. Use next. Just a debug to make sure the next line is the correct one. Uniform ball double sided equals 1. Yep. So now we're going to loop through again. Grab all text and place in temporary object. Until closing bracket, till bracket equals 0, which means we have an equal number of opening and closing brackets. So the bracket counter right now is 1. From there, it goes up and up and up, up and down, up and down, up and down, till finally it reaches 0 again down there. So this will decrement at 1. Oh, come on. It'll decrement at 1. So this will tell me when to exit the while loop. Now I could have put this logic up there, but I just like to keep it separate. Okay, we need to keep adding to our temporary definition. So each time we come across a new line and the curly brackets haven't closed everything off, we're just going to use pushback on our lines array. So this whole object will just fill up with text. Just for debug. We'll see what we're chucking into that array. Yeah, so worth putting all that in there. Put in the final curly bracket. No, I know it would be over there. And then it goes on to the next one, that's fine. So cycle pull through that. So we now want to write all this. So this array here is basically an array of these. Each mesh will have its own one of these, which contains a whole bunch of text. That's where that temporary definite object comes in. And we're going to ignore the light for now, so let's make sure this compiles. Yep. And just going to do a debug. Oh. Debug function here. Make it chainable. New. Debug. So this debug calls the other debug, which displays the contents of all this. No. Why doesn't it like that? Yeah, thanks C++. That makes sense. That was an error. Just debug. Let's run that. Put on a new line. There's the first one. Lay that out a bit better. Okay, so the first one. Okay. Why is it? Yep. While I'm here, we'll set up the one at the same time for the, is it a point light? Spear light, port light, and this. So the spear. Why doesn't it like that? Of course. Okay, we now want to create a private function, a method. Essentially, all of this I want to put into its own method, so we don't have to keep repeating ourselves, otherwise I have to repeat it for that, the same code. And that can lead to bugs, and it just ugly. So this will now just look like this, move into array. So what do we need to move? Type. Stream. Pretty much anything that's used. So we'll start with that. Just make sure that compiles. It shouldn't do anything yet. And of course it fails. Void. We're using that a bit. So let's move string stream. compile that. Yep, compiles. Okay, it's looping through that. Oh, why does it do that? Make sure that works. Yep, compiles. What else do I need here? There we go. We push everything into that. Move a reference of that. And that should be R. These are references, parameters, and references. Okay, make sure this compiles. Yep. So now we're just essentially moving all this in. And what breaks? R stream should be the same. R line. A line should become R line. Quite a few of those. String, stream. A string stream? Yeah. How many of those? One. It becomes R string stream. That's R line. Type doesn't seem to exist. Is it used? Oh yeah, it is used. And kind of, there you go. Kind of def. Do we even need that? Wouldn't hurt. At least for debugging purposes. That should be just def array. That's fine. Just run it. Yep. Fail. Come on. Yep, they compiled. The beauty of that, this is all now cleaned up. And we can do the exact same thing for any other definitions, just by adding one line. And changing the array. That it gets pushed into. So this debug function at the moment it's just doing the mesh array. So you only see the plane, you don't see the light, so we need to do one for the light. Now we could have another array with an array, but then it'll be an array within an array within an array. And 6 months from now, I'm not going to make any sense of that. So even though this is repetitive, I think it's simpler. Okay, let's run this. Okay, so we've got the plane. What is that? Point light. Something going on here. So let's look at this mesh array. Size. Size, I guess. Ah, that's not it. Size equals 1. There's only one plane. Point light, there's only one. What's that business there? Must be the debug. What is that? So it calls blah blah. So that'll do for now. I think next time we'll look at, say for example, the plane text, which is all that. So the second pass, we'll go back in and pull out the information here, such as the normals, points, UV information, texture file, indices to these points, and anything else that's relevant. And we place it into the GeoResources class that we created earlier. Then we can send that data to the graphics card using the Vulkan API to draw the that quadrangle on the screen. And I should be able to, this GeoResources file just get bigger and bigger, so I need to make some modifications to that. So as we keep chucking geometry into it, the indexing is incremented, which will make sense when I actually do it. So yeah, we'll leave it there. Okay, thanks, bye.